Hello everybody and welcome to today's Physics 12 lesson. For today's lesson, we're going to be talking about right-hand rules. And more specifically, we're going to talk about two right-hand rules. But to start off and get into these rules, we need some background information. And this background information is going to be on the magnetic field around a magnet, which you probably learned in a previous lesson, but let me just remind you guys how it works. As you can see, right here we have a magnet, and these lines which you see going like this, and this, and this is the magnetic field around a magnet. As you can see, it goes from south to north and out north like this and into south like this, but it also goes back from north to south. And I want you guys to remember this, as this is how the magnetic field works around a magnet. So, our first topic for right-hand rules is Ampere's law, also known as our curl right-hand rule. And you'll learn very soon why it's called the curl right-hand rule. So, to start off, let's take a look. And you'll need to know two things for this. First, you'll need to know what into the page is. And next, you'll need to know what out of the page is. So, for into the page, it's very simple. It's an X. And for out of the page, it's a dot. And you might be thinking, an X and a dot, why is that used? And I can explain it to you. It's fairly easy. An X represents the tail feathers of an arrow, and a dot represents a tip of an arrow. And if you think about it, for example, let's say you shot an arrow in front of you. When you shot said arrow, you would see the tail feathers of the arrow as it's going away from you. But when an arrow is coming towards you, what would you see? The tip of it. Thus, we use tail feathers to represent something going into the page, away from you, and a tip to represent something coming out of the page, towards you. And these signs can be used for many things to show force, magnetic field, and current, of course. Now, moving on, this is our curl right-hand rule. When there's a wire, you take your hand with your thumb in the direction of current. For example, let's take this first image we have, and let's say current is going this way. This color is a bit too similar. Let's use this. Let's say current is going this way, up. With current going up, and the wire is also traveling up, we would put our hand out, our palm facing the wire, with the thumb going up, because that's the way current is flowing. And then we would wrap our fingers around that. And as you can see, the wrapping motion you make, it goes in. Your hand first points in towards something, then it wraps around it. And if that's a bit hard to follow and hard to understand, don't worry, as we're going to be working and doing examples with this. So let's read our first question. Draw the corresponding signs to show which side of the magnetic field is going in and which side it is coming out. And from here, we can remember into the page is an X, out of the page is a dot. So with this arrow right here, we can see that current is going this way. This is the way of current. And when we see current is going this way, towards your left, we can stick our hand out, and for simplicity's sake, let's make our palm face the air. Our right hand, of course, because it's the right hand rule. Right now, our thumb is facing our right direction, which can't be good for this because we need to make it face the left. So we flip our hand over. Palm faces the ground, our thumb faces the left, which is the way our current is going, and our fingers are straight right now. Now we curl our fingers. What are our fingers doing? Pointing at us. And from the bottom, which way our fingers are pointing, is what's coming out, as it curls in and comes out. So I want you to think about it. It curls in, as it curls in and it goes out. So you're curling in from here, right? As if you should be doing this with your hand. and it's coming out as your fingers are pointing out towards you from the bottom. And now, this should make sense, but if you're still having difficulty, you can use it with your hand right now. Keep your hand out, palm on the ground, thumb towards the left as the direction of current. Fingers are going into the page and they're curling out towards you. And if you're grabbing the wire, fingers are on the bottom of the wire, they're pointing out towards you, and at the top, they've already gone in to grab it. Now, let's look at this example. Which way is the current going? So this thing has given us two options. The current's either going this way or this way. So we don't know which way to point your thumb. So let's see if we can tell with these signs. This is telling us it's coming out of the page from the top, and it's going into the page from the bottom. Let's test this with our hands. First, let's test the way pointing left. Say we stick your thumb towards the left, palm facing down, and fingers wrapping around the wire. We can see that this doesn't work out because for that, this is what happens. If current's going towards the left of the wire and our fingers are wrapping around it, our fingers are showing that the magnetic field is going in from the top and out from the bottom. And we can see that's not the case here. So let's test the other way. Now, let's have our palm face the ceiling, of course, as our thumb is going to be pointing towards the right direction, the fingers curling up. And now we can see that this works as our fingers are going into the page from the bottom and our fingers are coming out of the page from the top. This shows that the magnetic force is coming out, or magnetic field, well, I should say. So we can tell that the correct answer should be this, towards the right. So current is traveling right. Or if we want to get technical, northeast, southwest, east of the wire. But right is fine. Now let's go into our second rule, also known as the solenoid rule. You see, the solenoid rule works with a solenoid, and I want you to learn and remember that a solenoid is essentially a bar magnet. It works exactly like a bar magnet. So, as you can see with this first image that we're going to work with, our thumb is pointing towards the right, and our fingers, our hand, is fully wrapped around the solenoid. As, apologies, for the solenoid rule, you wrap your hand around the solenoid, and the way your fingers are going is the way the current is moving through the solenoid's wires, and the way your thumb is pointing towards the north end. As remember with the bar magnet, let's go ahead and look at how magnetic field works around it. As we can see here, magnetic field goes from south to north for a bar magnet, correct? So let's move back here, south to north, thus our thumb is facing towards the north end. Same here, south to north in the second diagram, thus our thumb faces north, points towards north, and our hands wrap around the solenoid in that direction. And as you can see right here, I've written it down as well, solenoid acts like a bar magnet. Now, I know this might be difficult to understand, so let's look at it more precisely with an example. So what is the polarity of the solenoid? Okay, let's take a look at this. So we can see that this is going into it, and this is coming out. And we can only assume this to be the magnetic field going in and coming out of the solenoid. And let's think about this. If a solenoid works exactly like a bar magnet, let's go look at our magnet example. In from the south, out from the north. In from the south, out from the north. Let's go look at our solenoid. In from 2, out of 1. So 1 must be our north. So we can eliminate what doesn't have north in it. south, south. So these bottom examples are eliminated. And 2 must be our south because it's going in and out. So let's look. This says north and this one says north. So this one can't be it because this one already has south, south. So we're going to cross this whole one out. This one's all already crossed out. This one's north, north. Can't be that. We're only left with one, north and south. So the second option here is our correct answer. And you see, it's a very simple way to tell the polarities of a solenoid, as it's exactly the same as a bar magnet. Magnetic field is coming from your south out towards your north. And you need to remember that, as those are the basics of a solenoid. Now, moving on to our next examples, we can see that it asks us to draw the magnetic field lines and put in the current direction for each of the solenoids below. So let's look at this. We can see that for our first example, this is north and this is south. And we have to think north and south. How does the polarity work with those? We do remember it because let us refer back to our magnet from our first page. We can see that it goes in from south out of the north. And let us refer to this solenoid image right here, where we've understood that this side is our north, and this side is our south, in from the south, out from the north. So we can easily draw our magnetic field lines in from the south, out of the north. And you can see that is our magnetic field. Now, it also asks us to put in the current direction. That is something we haven't been able to try with our last example, but we can refer back to these images we have right here. As you can see, the hand is wrapping around the solenoid, and the way your fingers are pointing then is giving you your current direction. As let us look at this image right here. This right here, with the arrow pointing up, the arrow pointing this way, is meant to represent the current direction, as current is going up this wire, into it, looping around the solenoid. As their fingers cover most, but this wire would be going up, this wire would be going up, this wire goes up, then as you can see, it loops around, and if you could see the wires here, would loop around, and the current from the wire comes down like that. Now let us move back to the example questions we have, and let's take a look at this. We know the way that north is and south is and the way our magnetic force is going, so we can wrap our hands around like that. As we look at these images, thumb towards north and hand fully wraps around the solenoid. So let us put our thumb towards the north end, so our palm is going to be facing down, thumb towards the left side, which is the north end, and let us wrap our hand around it. Now, as we have our hand wrapped around it, look at the way our fingers are moving. Assume this isn't on the ground, assume this is right in front of you, as it might be easier that way. And as your hands are wrapping around it, your fingers are going down, up, and then down, but they're going up initially. And as we can see right here, this plus sign is where it's going to be coming from, the current. It's going to be going up, and then it'll just be going down like that. And then from here, it's going up here, and then it just goes down as we see, and then it slowly moves back up, and then it's down, then it slowly moves back up again, then down, and finally it finishes right there. Now, if that example wasn't enough, we have another one, and with this one, our polarities are flipped, so we can see both ways that we would most likely see a solenoid. Now, we've already known, and we've already tested how the polarity will work, as we know that it's exactly like a bar magnet. So we know this is how the magnetic field lines will look around our solenoid. And we can see that we need to start from here, and let us wrap our hand around this, but now with our hand facing towards our right, because that's where our north is. And let's wrap our hand around it and look at which way our fingers are going. We can see your fingers, but they're not pointing in any direction away from us initially. They point and fold in towards us. And even if that may be hard, we can just follow the lines. As let's say current goes in from here, in there, and it comes back out here. Let's say it's going in here, and then it comes out again, and in from that, and it loops back around and out, and it finishes right here. And you see, let's pull our hands out again, and let's try the solenoid rule with the right hand. It's exactly the way our fingers are pointing towards us. We have 4 fingers towards us, and luckily the solenoid has 4 loops for us to represent our 4 fingers, and our current is coming down towards us, which is just perfect. And let us look at our first initial example, this one. This is example number 2, and we can see our 4 fingers are wrapping in away from us, right? The initial wrapping is going up above the solenoid, and then it points at us only under the solenoid. So the wires on top of the solenoid are going over it like this, in this direction. So this would be the direction of the current for the first solenoid. But for the second one, we can see that this is the direction of the current. And this is all very simple, as it works perfectly with our solenoid rule. And this is what I would like to conclude my lesson on right-hand rules with. And let us just summarize this before I finish. We learned 2 things. Firstly, we learned Ampere's law, which is also known as a curl right-hand rule. Also, we learned what into the page is shown as and out of the page, which we've used for our curl right-hand rule, showing which way the magnetic field is going around a straight wire with current traveling through it. And we've also done this second example where we tested which way current is going based on the magnetic field and the 2 signs we learned into the page and out of the page. After, we learned the solenoid rule, and we've learned that a solenoid is exactly like a bar magnet. Let me write that out again. Solenoid works like a bar magnet. And you see, this is something that we need to remember, because understanding the magnetic field and how a bar magnet works is the key for how a solenoid works. As just look at this example we did, this example number 1 on this page down here. Exactly how it would work with a bar magnet. For example, let's say we had a bar magnet, north end, south end. Our polarity would travel just like how we've shown here, going in from the south end, and then eventually coming out from our north end, just like this, just like a bar magnet and just like a solenoid. And lastly, we've tested and we've seen how our current flows through a solenoid, and we've checked as well how our magnetic field lines look for the solenoid, because once again, it's like a bar magnet. I would like to thank everyone for listening and paying attention, hopefully, to my physics lesson. And I would like to recommend that everyone try a few more practice questions based off of the curl right-hand rule, also known as Ampere's law, and the solenoid rule, as those are the 2 main things that we learned today. So thank you a lot, everyone, and I wish you the best.